Good everyone, welcome to the conclusion of the last class, logarithm. We were able to do justice to the first two questions. Now we'll be starting with the third question. Enjoy the class. Here's the third question. Now to solve this, we'll be using the first and second rule to do the justice to the numerator and the denominator here. And by so doing, this becomes log base 10 0.04 times 0.25 and over log base 5 100 divided by 4. On doing that, this becomes log base 10 0.01. When this multiplies this, you get 0.01 over log base 10. 4 in 100 give us 25. Okay, this is base 5. So now this can be in the base 10. We can write 0.01 in the base 10, likewise 25 in base 5. So let's do that and see. This becomes log base 10 raised to power minus 2 over this will be log base 5 raised to power 2. Now when you bring this using the third rule, when you bring this one over, this becomes 2 minus 2 log 10 all over 2 log 5. So this becomes 1, this also becomes 1, so this becomes minus 2 times 1 over 2 times 1. So on dividing this, you have minus 1 as our final answer. That will be that for question number 2. Number 3, let's manage question number 4 somewhere in this corner here. Let's manage it here. So from question number 4, we have the same base, so plus and minus, we are using the first and second rule. This becomes log base 2 into bracket 4 times 7, then divided by n equal to 1. Now also, when you simplify this further, this should give me log base 2 28 over n equal to 1. And if you go back to the law 3, you will see that you can write this as log 228 over n. This becomes log base 2. Log base 2 should give me 1. So from here, if that being the case, this log base 2 is common, so we can divide through by log base 2. So by so doing, this becomes 28 over n equal to 2. Then from here, 28 is equal to 2n. Then my n is equal to 28 over 2, which is equal to 14. So that's question number 4. Let's go to question number 5. Question number 5 here, if you can see clearly, you can see there's no where we can apply any of the rules here, but to do this, we can just simplify this fraction, multiplying through by the LCM, which is log base 3x. So by so doing, this will give me, when I multiply this one by the LCM, this will be log base 3 times log base 3, which is log base 3 raised to power 2, minus, multiply this one by log base 3, that's 6 log base 3x. Then when you multiply this becomes minus 9. So when I bring in this minus 9, this becomes log base 3x raised to power 2 minus 6 log base 3x plus 9 equal to 0. Still, there's nothing we can do here, but if you look at it clearly, this looks like a quadratic equation. So we can say let P be equal to log base 3x, so that p raised to the power 2 minus 6p plus 9 will be equal to 0. Solving this will give me p minus 3 multiplied by p minus 3, which is equal to 0. So meaning p will be equal to 3 twice. So in this case, don't forget we said p is equal to log base 3x, which implies that I'm saying my 3, which is my p now, is equal to log base 3x. Now from the interpretation that we know already, so we are looking for the result here, which is going to give me 3 raised to power 3. So x now, therefore x will be equal to 3 raised to power 3, which is equal to 27. So that will be that for number 5. The last question we've gotten here. This question, if you notice, each of the time here looks like the note we took when we in the first video, where we said a raised to the power log ax is equal to x. So looking at this, we can make each of these terms look like this. So yes, of course we can do that. So a here, the base here also is the base of this logarithm. So can you see 5 is the base here and as well is the base of this logarithm. 2 is the base here and as well the base of this logarithm. So we can rewrite and make it look like this, so we can evaluate it. So from here I can rewrite this one to be equal to, using the third rule, this will become 5 raised to the power log base 5 2 raised to the power minus 3. So times 2 raised to the power log base 2 3 raised to power 2. Sorry, it's so close to the to this, so we just manage it there. So this becomes, from the analysis of this means this we evaluate to give me 2 raised to the power minus 3. So this means this becomes 2 raised to the power minus 3 times, then this we evaluate to give me 3 raised to the power 2, and this is equal to 8 raised to power minus, that's 1 over 8. This is equal to 1 over 8 times 9. So all this evaluate to give me 9 over 8. My final answer, or equal to 1 on number 1 over 8. So this means 1 all over, from our indices, this means 1 all over 2 raised to power 3. 2 raised to power 3 is 8. So that's 1 over 8. That's how we got 1 over 8. Thanks for watching. Hope you enjoyed the class. Please, if you haven't subscribed already, do that right now to the channel. Then hit the like button, share our video. Thanks for watching.